Lava flows, powerful eruptions, ash, poisonous gas, lahars, and earthquakes are all hazards that must be anticipated while volcanoes create new land from deep within Earth.
Glimpses of the past. Kamehameha V. In 1868, the island of Hawaii was devastated by two powerful earthquakes, a large eruption, a tsunami, and a mud flow. Many people were killed and many villages destroyed. Kamehameha V, who reigned as king from 1863 to 1872, instantly provided food and supplies to the areas of greatest damage, reducing the suffering of his people. Kamehameha V, born in 1830, was a bachelor with no children. He died without naming a successor, prompting his kingdom to hold its first election.
Capturing volcanoes. Capturing volcanoes. For more than 20 years, French scientists Maurice and Katia Kraft studied, filmed, and photographed volcanoes around the world, often focusing on dangerous eruptions. They are said to have witnessed and photographed more erupting volcanoes than anyone else in history. Tragically, on June 3, 1991, they were killed with 39 others by a pyroclastic flow erupting from Unzen volcano in Japan. Maurice and Katia Kraft. Maurice and Katia met at the University of Strasbourg before graduating with degrees related to the study of volcanology. In 1968, they founded a center in France dedicated to the study of active volcanism. After the eruption of Nevada del Ruiz in Colombia in 1985 that killed 23,000 people, the Crafts partnered with UNESCO to create two videos that showed how volcanic eruptions can impact people. These videos helped make the massive evacuation around the 1991 Mount Pinatubo eruption in the Philippines successful. Hawaiian warnings. Hawaiians have issued warnings about volcanic hazards since ancient times.
Traditional observations. Oli, chants, and stories were devised to warn others about volcanic hazards. An oli could describe the location of sharp lava, steam vents, and skylights, as well as shelter and drinkable water along a well-traveled route.
Observations today. Scientists warn Hawaiian residents about volcanic hazards with hazard maps, colored alert level codes, and computer-based updates on websites around the world. Alert level codes. Colored alert level codes let residents know the likelihood of an eruption. Once a volcano is erupting, this scale is no longer used. Green normal. Green normal is the normal, non-eruptive state of a volcano. Yellow advisory. Yellow advisory indicates that monitors report values outside normal range and could be a precursor to an eruption. Orange watch. Orange watch indicates either 1, that monitors report values well outside normal range and an eruption is about to occur, or 2, an eruption that poses only a local hazard is occurring. Red alert. Red alert indicates that a potentially hazardous eruption is about to occur or is occurring. A red alert indicates a potential threat to life. Action to mitigate the threat should be taken. Lava flows. Extremely hot lava flows consume or bury everything in their path. Because most lava flows can be outrun, they pose a hazard mostly to houses and other structures. Lava flows also can ignite forest fires. Ocean entry. Lava entering the ocean creates hazards for humans, fish, and wildlife. These hazards include scalding, silicosis, and bench collapse. Scalding. When lava enters the ocean, it can heat surrounding water to boiling for about 100 meters around the point of lava entry. This hot water can scald fish, wildlife, and people. Lava heats water by circulating in a unique pattern. Temperature zones. Water heated by lava on the ocean floor convects to the surface and cools, creating an upwelling that divides the flow of hot water. From the point of entry on the coastline, the hottest water is concentrated in 2 zones flowing around the upwelling. This infrared photograph emphasizes the temperature contrasts of the ocean's surface. Temperature zones. Ocean entry. Silicosis. Lava mixed with ocean water can create gigantic bubbles which can burst into billions of small shards of glass that are carried away in steam. These bits of glass can damage eyes and become embedded in noses and lungs, causing a disease called silicosis. Ocean entry. Bench collapse. Lava entering the ocean can create lava benches, new land that juts out and extends the coastline. These benches are often unstable and can collapse without warning. Volcanic ash. Ash from a volcanic eruption can be hazardous in the air and on the ground. Scientists have developed computerized models to predict where ash will be transported by wind. Computer predictions. Computer models help scientists predict where ash plumes will travel. Computer predictions of actual ash plumes from eruptions of volcanoes in Alaska, Italy, and Iceland were tracked by Puff, a computer program that predicts where ash will travel as it is transported by wind. Puff tracks ash from the eruption of Mount Cleveland in Alaska on February 19, 2001. Red stars indicate when ash was observed by airplane pilots. Computer predictions. Puff tracks ash from the eruption of Mount Etna in Sicily, Italy, on July 22, 2001. Computer predictions. Puff tracks ash from the eruption of Mount Hekla in Iceland on February 22, 2000. Computer predictions. Volcanic ash. Airborne ash. When volcanoes erupt, ash can spew into the atmosphere where jet aircraft fly. In the movie above, a 1983 passenger flight was interrupted when ash from the volcano Gelungnung, Indonesia, was sucked into aircraft engines, causing them to shut down. Ash also scratched cockpit windows before pilots were able to start aircraft engines again and make a safe landing in Jakarta, Indonesia. Volcanic ash. Ashfall. The weight of falling ash can cause buildings and other structures to collapse. Thick ash in the atmosphere can cause darkness in the middle of the day. When ash is inhaled, it can cause serious health problems. Pyroclastic flows. A pyroclastic flow is a superheated cloud of ash, gas, and rock that rides a cushion of air down the slopes of an erupting volcano. Pyroclastic flows can travel up to 150 miles per hour, 242 kilometers per hour, overriding hills and ridges and knocking down everything in their paths. Temperatures within these hot, fast flows can reach 800 degrees Celsius. Lahars. Lahar is an Indonesian word for mudflow, which is a slurry of water and rock flowing down the slope of a volcano. Lahars can be triggered when heat from a volcano rapidly melts glacier ice and snow, or when intense rainfall saturates unstable ground. Volcanic gas. Erupting volcanoes produce lots of gas, much of which is toxic to humans and plants. Harm can come directly from the effects of the gas or indirectly by destruction of food crops and animals. An atmospheric condition called laze occurs after lava reacts with ocean water, creating large steam plumes laden with hydrochloric acid. Sulfur dioxide. Sulfur dioxide is a poisonous gas. When inhaled, it can penetrate deeply into the airway, causing respiratory problems, including asthma attacks. In water and air, sulfur dioxide can create fog and acid rain. volcanic smog. VOG is a visible haze created when sulfur dioxide reacts chemically with sunlight, oxygen, dust particles, and water in the air. VOG is a mixture of gas and tiny liquid and solid particles composed mostly of sulfuric acid. VOG can cause coughing, difficult breathing, and burning eyes. Sulfur dioxide. Acid rain. When combined with water vapor, volcanic sulfur dioxide forms sulfuric acid that falls to the ground as acid rain. This rain damages vegetation and creates high acidity in soils, lakes, and streams, making it hard for plants and fish to survive. Acid rain also can accelerate building decay and leach harmful chemicals into household water supplies. Sulfur dioxide. Volcanic gas. Carbon dioxide. Carbon dioxide is a colorless, odorless gas. Because it is denser than air, it can flow downhill from volcanoes and collect in low-lying areas. Animals and people in areas filled with carbon dioxide will suffocate. Volcanic gas. Erupting volcanoes produce lots of gas. Earthquakes. Vibrations from earthquakes associated with active volcanoes can shake the ground, causing structures to collapse, and can trigger other hazards, such as landslides, tsunamis, and avalanches. Landslides. Earthquakes can trigger landslides. This small landslide from a cinder cone partially blocked Chain of Craters Road in Hawaii Volcanoes National Park. Earthquakes. Tsunamis. A tsunami is a massive wave that can follow an earthquake or underwater landslide. Tsunamis begin as a series of long waves of different amplitudes that extend for miles. Developing tsunamis move at the speed of a jet aircraft, slowing only when they reach coastal areas. There, tsunamis grow in height as a rapidly rising tide that can engulf coastal communities. Earthquakes. Avalanches. Snow and rock cascade down a mountain after an earthquake in Alaska. Shield and composite volcanoes. The danger posed by each volcano hazard is a combination of its impact and how often it occurs. The impact can be measured both in terms of death and monetary damage. Shield hazards. Most destruction associated with shield volcanoes is caused by hot lava flows. CO2 emissions also can be deadly. While rare, shield volcanoes can be explosive. Explosions near a coastal area can cause bench collapse. Lava hazard. Because most lava flows can be outrun, they pose a hazard mostly to houses and other structures. Shield hazard. Carbon dioxide hazard. Carbon dioxide is a silent and deadly killer. This invisible gas is heavier than air, so it stays close to the ground, flows downhill, and can settle in low-lying areas. Shield hazard. Shield and composite volcanoes. Composite hazard. Most death and destruction associated with composite volcanoes are caused by pyroclastic flows and ash, lahars, and tsunamis. Pyroclastic flows and ash. Pyroclastic flows are extremely hot, move faster than a person can run, and can override hills. These lethal flows knock down, kill, or burn everything in their paths. Composite hazard. Lahars. These churning mud flows of water and rock can destroy trees, bridges, houses, and other structures in their paths.